Good morning, this is C. Rachana, Assistant Professor of Mathematics, Institute of Aeronautical Engineering. In the last session, we have discussed about general solution of the linear ordinary differential equation with constant coefficients. So, based on Q of x, we have different particular solutions. So, in the last sessions, we have discussed where Q of x equal to exponential function and one more case where Q of x is sin ax or cos ax. Now, in this session, I am going to discuss about particular integral where Q of x equal to x power k. So, in the case, how we can solve particular integral and how we can take the complete solution of the given differential equation with a constant coefficient. So, general solution of f of d into y equal to q of x. Here, particularly q of x equal to x power k, where k is a constant. So, already we have solution of the linear differential equation with a constant coefficient f of d into y equal to q of x. What is the complete solution of this f of d into y equal to q of x? Y equal to yc plus yp. What is yc and what is yp? Yc is nothing but the complementary function and yp is nothing but particular integral. Yc based on the roots we get yc complementary function and yp we can get based on q of x. So this is the third case where q of x equal to x power k, where k is a constant. So in the first method, q of x is exponential function e power x, and the second case where q of x equal to sin ax or cos ax. In this case where q of x equal to x power k, here k must be not equal to 0. If it is 0, x power 0 become 1, which is again go for any method, either first method or this method, third method. So better in this case, k must be not equal to 0. And already we have solution of the linear differential equation is nothing but y equal to yc plus yp. Yc is nothing but complementary function and yp is nothing but particular integral. In any method, complementary function is same, that is based on the roots we form complementary function, and particular integral we find by using x power k. So here k is not equal to 0. So now here we have to find yp where q of x equal to x power k. What is the method and how we have to find? Now in this session we have to discuss. Now generally the particular integral of a given f of d into y equal to q of x is yp equal to 1 by f of d into q of x. F of d is nothing but operator form of the given differential equation and q of x is nothing but x power k. K is not equal to 0, which is compulsory constant. So how we can find and how we can solve this particular integral where q of x equal to x power k? So generally we have particular integral is 1 by f of d into q of x. F of d is nothing but operator form of the given equation, given differential equation. So whatever f of d and whatever the order of the differential equation, take the least term common. Suppose we have d square plus 2. In this, what is the least term? 2. Take 2 common and we have 1 plus d square by 2. So any term, any f of d, take 2 common and we'll get 1 plus something. So we have some standard binomial definitions to expand this one. So that's why we have to take least term common in any function f of d. So take 2 common, we have 1 plus d square by 2. So if we take 1 by f of d, I am writing generally 1, sometimes we have plus term or we have minus term. If we take any term, least term common, we have to take that into 1 plus or minus phi of d. Phi of d is nothing but some function. In this, what is phi of d? D squared by 2. So whatever f of d and whatever order of the polynomial, take a least term common. The least term is here 2 in this example. Take 2 common, then I have 1 plus d squared by 2. This is of the form 1 plus phi of d. Whatever the denominator, take into numerator, will get 1 plus or minus phi of d whole inverse. Either sometimes we'll get plus phi of d or sometimes we'll get minus phi of d whole inverse. Now hence the particular integral become 1 by 1 plus or minus phi of d into q of x. 1 plus or minus phi of d whole inverse into x power k. Here q of x, in this case we consider only x power k. For only q of x is x power k, we follow this procedure. If it is sine or cos, we have previous method. If it is exponential, we have another case. Based on q of x, we are following this case. So whatever f of d, and take 1 plus something form. So the another form is, let it be phi of d, take into numerator form, which is 1 plus or sometime minus phi of d whole inverse into x power k. Now here we have some standard formulas. What are those? So any form or any polynomial equation, we have to change that into 1 plus something. So we have some standard forms. So everyone should remember this: 1 by 1 minus d and 1 by 1 plus d. And sometimes we have second order also. In this case, we have to take 1 by 1 minus d whole inverse, 1 by 1 plus d whole inverse, like that. So here we have standard formulas. By using binomial expansion, we have all these formulas. So what is 1 plus d whole inverse and what is 1 minus d whole inverse? So f of d anyway, which is in the denominator. So if we take into numerator, definitely we'll get power minus 1. So 1 minus d whole inverse become, here we have minus numerator and power, definitely we have negative only. Either minus 1, minus 2, minus 3 and so on. So 1 minus d whole inverse become 1 plus d square plus d cube plus and so on. So for expansion, I'll tell you after this slide. So based on the problem, based on q of x, we have to expand the term. So here you should remember one thing: 1 minus d whole inverse. Here also minus, power anyway which is minus. So 1 minus d whole inverse become, all the terms should be plus. 1 plus d square plus d cube plus and so on. If 1 is plus and power is minus 1, like 1 plus d whole inverse. So if any term or any function having like 1 plus phi of d whole inverse become, we have to take alternately plus and minus. So what is 1 plus d whole inverse? 1 minus d plus d square plus minus d cube and so on. Based on q of x, and k is here constant, which is a power. So based on that power, we have to expand the given binomial function. So 1 plus d whole inverse is nothing but 1 minus d plus d square minus d cube and so on. So now go for 1 minus d whole power minus 2. In the previous two formulas, we have only power minus 1. So if it is minus 1, power minus 1, very simple. If here minus and here minus, we have 1 plus d square plus d cube plus and so on. And in the next one, 1 plus d whole inverse means alternately plus minus. Anyway, first term become plus 1. 1 minus d plus d square minus d cube plus so on. If k is 2, we have to expand up to second order. If it is k3, we have to expand up to third order. If it is 4, we have to take up to d power 4th term. So, and next third formula, 1 minus d whole power minus 2. Here power is minus 2. And here also minus, power anyway we have minus 2. So, when we have 1 minus d whole power minus 2, we have 1 plus 2d plus 3d square plus 4d cube plus so on. So this formula you have to remember: 1 plus 2d plus 3d square plus 4d cube plus so on. And similarly 1 plus d whole power minus 2. What is 1 plus d whole power minus 2? Here plus and power is minus 2. So we have to take alternately plus and minus. So 1 minus 2d plus 3d square minus 4d cube plus so on. So if it is plus and minus, we have alternately plus minus. If both are minus, we have all the terms are positive. Now go for fifth problem. Here we have fifth formula, that is 1 minus d whole power minus 3. What is 1 minus d whole power minus 3? In the previous we have power minus 1 and power minus 2, and here we have power minus 3. 1 minus d whole power minus 3 means 1 plus 3d plus 6d square plus 10d cube plus so on. 1 plus 3d plus 6d square plus 10d cube plus so on. The coefficients must be remembered. So 3, 1 plus 3d plus 6d square plus 10d cube plus so on. If it is minus 2, we have 1 minus 2d plus 3d square plus 4d cube, like that. If it is minus 3, we have only 1, 3, 6, 10. These are the coefficients. By using binomial expansion, we have all these formulas. 1 minus d whole power minus 3 is nothing but 1 plus 3d plus 6d square plus 10d cube and so on. And similarly, last one more, 1 minus d or 1 plus d power minus 3. Here we have 1 minus d power minus 3, and this is 1 plus d power minus 3. What is 1 plus d power minus 3? 1 minus 3d plus 6d squared minus 10d cube plus so on. So these are the formulas. These formulas we have to remember to solve the problem, that is particular solution where q of x is x power k. Now here we have one problem having y triple dash plus 2y double dash minus 2y equal to 1 minus 4x cube. So this is the derivative form, differential equation of order 3. Here we have y triple dash. Triple dash means this is the differential equation of order 3. So first we have to write whatever the differential equation in the operator form. What is the operator form of the given differential equation? D cube plus 2d square minus d minus 2 into y equal to 1 minus 4x cube. So this is the operator form of the given differential equation of the form f of d into y equal to q of x. Here what is q of x? 1 minus 4x cube. So in place of 1, we can consider either x power 0 is 1, and also similarly e power 0x also 1. So where q of x is exponential term, which is very simple, just in place of d we replace a. This is the first method. So, and the second case is here minus 4x cube. And how we can find if it is x cube, we'll see later. So now the given equation is f of d into y equal to q of x, which is the operator form. Now first to find the solution of complementary function. What is the complementary function? Based on the roots, we write complementary function, that is yc. So first for the given differential equation, write the auxiliary equation. What is the auxiliary equation? In place of d, take m. What is d here? F of d. F of d is nothing but differential equation which is in the operator form. In place of d, take m. So then we have m cube plus 2m square minus m minus 2 equal to 0. So what are the roots for this polynomial? If it is a third degree polynomial, we'll get 3 roots. The roots are here m square minus 1 and m plus 2. By using synthetic division, we will find roots. What is the synthetic division? Take the coefficient of the given polynomial. What is the highest degree here? 3. What is the coefficient of m cube? 1, 2, minus 1, minus 2, which is 0. And let's first consider one root which satisfies that polynomial. So already here we have m plus 2. Nothing but one root is here, minus 2. If you take minus 2 and substitute, then you will get remaining 2 roots. So 1 minus 2 is minus 2. 2 minus 2 become 0. 0 is 0, minus 1, Minus 1 into minus 2 become 2. So last we have 0. And by using this, and this is like a d square or m square minus 1 equal to 0. So here we have two fractions. One is m plus 2 and another one is m square minus 1. If we take equal to 0, we'll get the roots. We want roots. Based on the roots, we write complementary function. What are the roots here? M square equal to 1 and another one is m equal to minus 2. So if it is m square equal to 1, we have m equal to plus or minus 1 and another one is m equal to minus 2. So here we have three roots. The three roots are real and distinct. So given differential equation is third degree differential equation, third order differential equation. So definitely we'll get three roots. The roots are here real and distinct. If roots are real and distinct, we have to write the complementary function. How we can write complementary function if roots are real and distinct? YC. YC is nothing but complementary function, which is nothing but c1 e power x, nothing but c1 e power m1x. m1 is nothing but first root. m2 is nothing but second root. m3 is nothing but third root. So c1 e power x plus c2 e power minus x plus c3 e power minus 2x. These are the three distinct roots. We write the complementary function based on the roots. Here the roots are real and distinct. Now this is a complementary function. This is the half of the solution of the given differential equation. Now next we have to find particular integral. How we can find particular integral? General formula for any method or for any q of x, we have particular integral equal to 1 by f of d into q of x. In this case, q of x is nothing but x power k. So 1 by first write f of d. What is f of d here? D cube plus 2d squared minus d minus 2 into q of x. What is q of x? 1 minus 4x cube. So what is the case in this? Whatever f of d, take the least term common from that f of d. Here the f of d is minus 2. Take minus 2 common. So minus I am writing in the numerator. Take 2 in the denominator. We have 1 minus d cube plus 2d square minus d by 2 into q of x is as it is. Don't disturb anything. So minus 1 by 2 I am writing outside, and which is like 1 by 1 minus phi of d form. What is the next step? Take that 1 minus phi of d into numerator. If we take into numerator, that will become minus 1. So 1 minus d cube plus 2d square minus d by 2 whole inverse into 1 minus 4x cube. Take minus 1 by 2 common, and this is like which form? 1 minus d whole inverse form. What is 1 minus d whole inverse? 1 plus d square plus d cube plus so on. So here we have minus, here also minus. If both are minus means we have all the terms are positive. 1 minus d whole inverse is nothing but 1 plus d square plus d cube plus and so on. So minus 1 by 2 into, and which up to which term we have to consider? Here we have x cube, means we have to consider up to third term. Now multiply. D cube already we know. D cube is nothing but 3 times we have to take differentiation. D square is nothing but 2 times we have to take the differentiation. D is nothing but 1 time differentiation. Like that, multiply this term into 1 minus x cube, second term into 1 minus 4x cube, third term into 1 minus 4x cube. First term anyway 1, so anyway which is become 0. And go for the 4x cube. Take maximum possibility is only we have to take differentiation 3 times. So take that, we get 1 plus 1 by d into d cube plus 2d square minus d plus 1 by 4 into d square minus 4d cube plus 1 by d into, in the last term we have only minus d cube. More than d cube, we will get x cube become vanish. If we take x cube, one time differentiation is 3x square. Second time is 6x, and one more time is 6. X cube we have to take 3 times derivation. So now multiply 1 minus 4x cube into this one, we'll get minus 1 by 2 into 1 minus 5 by 8 into d cube plus 5 by 4 into d square minus 1 by 2 into d into 1 minus 4x cube. We'll consider what are the possibilities only we'll consider. So minus 1 by 2 into multiply both the terms. We'll get finally 2x cube minus 3x square plus 15x minus 8. After simplification, you will get 2x cube minus 3x square plus 15x minus 8, which is the particular solution of 8 q of x equal to 1 minus 4x cube. Sometimes we have to split and we can take the solution yp also. Take 1 is separate and 4x cube separate and write to 1 by f of d like 1 plus r 1 minus something. In this case, we have 1 minus d whole inverse. 1 minus d whole inverse means both the terms are minus. So we have 1 plus d square plus and so on. All the terms are positive. So after simplification, you will get 2x cube minus 3x square plus 15x minus 8. Now individually yp is not a solution. Individually yc is not a solution. Both yc and yp will give the solution. So the general solution is y equal to yc plus yp. Already we know yc term, that is complementary function. So in this problem we have three roots of real and distinct. So we got yc is c1 e power x plus c2 e power minus x plus c3 e power minus 2x. And in previously we solved yp. What is yp here? 2x cube minus 3x square plus 15x minus 8. So yp is nothing but in place particular integral y equal to yc, and here we have yp. Y equal to yc plus yp is nothing but general solution for the given differential equation of the form f of d into y equal to q of x. But in this method, the q of x is x power k, which is very simple method. Nothing to worry in this case. Very simple. Whatever f of d, write 1 plus something form. 1 plus some function phi of d. Take the denominator into numerator. Nothing but we'll get sometimes plus and sometimes we'll get minus also. 1 minus phi of d whole inverse. This is like a binomial expansion. 1 plus d whole inverse or 1 minus d whole inverse into x power k. In this problem, we have 1 minus 4x cube. Sometimes we can split and we can find like yp1 and yp2. yp1 we can find by using 1 and yp2 we can find by using this 4x cube. So 1 plus or minus phi of d whole inverse become 1 minus d whole inverse form. If both are negative, we'll get all the terms are positive. 1 minus d whole inverse means 1 plus d square plus and so on into whatever it is, x power k or x power 2, x power 3. Based on k, we have to expand binomial 1 minus d whole inverse term. So then multiply both. D already we know, 1 time differentiation. D square is nothing but 2 times differentiation, and d cube is nothing but 3 times differentiation. So like this we have to find particular integral, and based on roots we find complementary function yc. Hope you all understood this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.